Hello and welcome back to Math Class in Session. I'm an Ontario high school math teacher and I'm trying to help my grade 10 math students with factoring. And in this video, let's look at factoring a difference of squares and a perfect square trinomial. First, let's see what happens when we multiply a couple of conjugates together. Conjugates are identical binomials except for the sign in the middle. So when we multiply these conjugates together, we get this. Now let's see where we're getting all of this. X times each of these terms, so it's x squared minus 4x. And 4 times each of these terms, so it'll be plus 4x minus 16. Now we notice that these two offset each other, and so they disappear, and we end up with just this, x squared minus 16. So, more simply put, the product of these conjugates is just x squared minus 16. This just shows why it's x squared minus 16. So if we could learn to multiply conjugates together, let's do it a couple of times. A plus 5 times a minus 5 is just the first term squared, subtract the second term squared. In the first case, it was x squared minus 16. In the second case, it's a squared minus 25. It's a difference of squares. In this case, let's examine these. These are conjugates. We can tell by the signs in the middle. And so the result is going to be a difference of squares, the subtraction of the squares. So 16y squared minus 9. Once one has learned how to multiply conjugates together, the process of factoring these differences of squares here becomes a matter of going backwards across those equal signs. We note that the right-hand side in each case is a subtraction or a difference of squares. So what happens is when we're presented with a difference of squares, a subtraction of two perfect squares like b squared and 81, for example, we just have to go backwards and say, well, what are the two conjugates that when multiplied together give me b squared minus 81? So one will have a plus sign, one will have a minus sign, and they will be the square roots of b squared and 81. One needs to know their times tables well enough to know that 9 times 9 is 81, so 81 is 9 squared. And if one knows that, then factoring it becomes an easy matter. It's just b minus 9 times b plus 9. Look at this. Factoring this becomes an easy matter. W minus 6 times w plus 6 in either order. Memorize. A difference of squares is a product of conjugates. Let's continue and factor this. A minus 16, well, this does not factor because it's not a difference of squares. A is not being squared. Continuing, a squared plus 16. Again, this does not factor because this is not a difference of squares. It's a sum of squares. Looking at this one, well, 18 is not a square, but if you can common factor an expression, then that's how you must start. Common factor first. And I see that 2 comes out of each term, so we common factor it out. And now one of the factors is a difference of squares. So this w squared minus 9 becomes w minus 3 times w plus 3 in either order. Again, factoring an expression, we try to common factor first if we can. And both 18 and 50 are even, so let's common factor out the 2, common factor first, and then note that the result is a subtraction of squares in one of the factors. And so that factor breaks down as a product of conjugates, 3x minus 5, 3x plus 5. In either order. Let's factor a perfect square trinomial. So let's say we had to factor this. Now, first of all, you have to recognize it as a perfect square, and this is how you can do that. First of all, notice that the bookends, those are the terms on the end, as I have nicknamed them. The bookends are perfect squares. One has to recognize 9 is 3 squared, and x squared is clearly x squared. So the bookends are perfect squares, and we also know that the middle term is 2 times the product of the square roots of the bookend. The square root here is 3, and the square root over here is x, so the product there is 3x, double that, and you've got this 6x in the middle. Now, if you notice that, then you've got the key that unlocks the door to this perfect square trinomial. First of all, you conclude that it's the square of a binomial, and it's the binomial x minus 3 squared. Now we'll go into how we develop this this square root of this perfect square trinomial in a moment. Let's factor a few of these. X squared plus 10x plus 25. We notice that the square root on the end here is 5, and the square root on the end here is x. 5x doubled is 10x, so we recognize this as a perfect square trinomial. So we set up the brackets and indicate that we are going to have a square of a binomial. What binomial? Well, it's the square root of x and the square root of 25. And the sign here will be what the sign that shows up here, a plus sign. We can check because we know how to square binomials. X squared, x times 5 times 2 is 5x doubled is 10x, and on the end, 5 squared is 25, and the end is always positive. Let's do it again. The square root here is 2x, and the square root here is 3. 3 times 2x is 6x, and double that, we've got 12x, which we see here in the middle. So we know that it's a perfect square. We set up the brackets to look like a perfect square. Inside the brackets goes the square roots of the bookend, so 2x and 3. And the sign we'll use is the sign that we see here. This sign must be positive, or it's not a perfect square. But this one can be plus or minus, and if it's minus, then it's minus over here, like that. We can check, because when we square this, we get 4x squared, we get plus 9, and we get minus 6x double, which is minus 12x. Again, taking a look at this one, the one bookend is 4x quantity squared, and the other bookend is y squared, so 4x times y is 4xy. Double that, you got 8xy. And you confirm, oh, that's a perfect square. So let's set it up as such and put the square roots on both ends. The square root of 16x squared is 4x. The square root of y squared is y. And we simply have to put that sign in. Doing another one, it's the same. Everyone is the same discussion. The square root of 9x squared is 3x. The square root of 25 is 5. 5 times 3x is 15x. Double that, you got 30x. Therefore, it's a perfect square. Set it up as such. And inside here goes the square root of 9x squared, which is 3x, and the square root of 25, which is 5, and this sign, which is a minus sign. Going again, it's never a perfect square if the end sign here is subtract. Notice all these were plus signs because this has to be a square, and squares are always positive. So this one doesn't work. It's not possible to factor this trinomial. Here we have, let's check this. So the square root here is 4, and the square root here is x. So 4x doubled is 8x. Well, this doesn't say 8x, it says minus 10x. So we're going to have to do it the other way that we learned how to factor trinomials, which is set up the brackets with the x in the front. Think of two numbers that multiply to 16 that add up to 10. 8 times 2 is 16, and they add up to 10. And then put the signs in as a last resort or a last afterthought that we need the signs to hit minus 10 on a number line. And that will be minus 8 and minus 2. More examples of factoring. If we see an even exponent, we know the expression is a perfect square. So this is a difference of squares. It's x squared squared minus 1. So when we factor it, we'll get x squared minus 1 and x squared plus 1. 1 is a perfect square. Now, this is pretty good, but the first factor is also a difference of squares. X squared minus 1 is a subtraction of squares. X squared plus 1 isn't, but x squared minus 1 is a subtraction of squares. So it too breaks down into x minus 1 times x plus 1, while x squared plus 1 remains. Here's another example of factoring. Now, this is a trinomial in x squared, because this is x squared squared, and this is x squared, and we'll need two numbers that multiply to 12 that are different by 1. So we'll set up the brackets with the square root of x to the 4th here, and the two numbers that multiply to 12 that are different by 1 are 4 times 3. And now we'll have to hit this target of minus 1 by going plus 3 minus 4, because 3 minus 4 is minus 1. This minus 1. And looking at the factors, we see that x squared minus 4 is a difference of squares. So it breaks down into x minus 2 times x plus 2. While x squared plus 3 is brought along like luggage at the airport. You just bring it with you. So you don't drop it, you have to bring it with you. And one last one, a bit of a challenge. We have 4 terms, but the first 3 is a trinomial in x. 9x squared plus 30x plus 25 is a trinomial in x. And we notice that the square root of 25 is 5, and the square root of 9 is 3, and 5 times 3 is 15. Double that, we have 30x. And so the first 3 is a perfect square. In fact, it's 3x plus 5 squared. Checking, we have 9x squared, 5 times 3 is 15, doubled is 30x, and plus 25. Now look at this. A difference of squares, the subtraction of two expressions that are being squared. And so it breaks down into 2 factors. The root of this minus the root of y squared, and the root of this plus the root of y squared. And the root of this is 3x plus 5 minus y, and 3x plus 5 plus y. Note that the internal round brackets don't have a meaning, so they can be dropped. That's the end of the factoring video, and I hope that it was in some way helpful for you.